Hello viewers, in today's class we are going to solve one important definite integral involving greatest integer function, right? So here we have the problem. We have to integrate this function greatest integer e raised to x divided by greatest integer 1 plus e raised to x from 0 to log of 2, right? So let us start. So let us first call this integral as I, right? So let us substitute t is equal to 1 plus e raised to x. So therefore dt over dx is equal to e raised to x, and from here e raised to x is equal to t minus 1, right? So here we have t minus 1. So therefore dt over t minus 1 is equal to dx. So this is the first relation, right? Okay, now see, here we are changing the variable x to t. So let us change the limits accordingly. So here we have we see that x is it varies from 0 to log of 2. So when x is 0, then the value of t is 1 plus e raised to 0, because here we'll substitute the value of x is equal to 0, right? So here we have 1 plus 1, e raised to 0 is 1, so we have 2, right? And when x is equal to log of 2, then the value of t varies or it is 1 plus e raised to log of 2, and e raised to log of 2 is simply 2, that is 3, right? Because e raised to log of p is equal to p, right? Okay, so now we can write this integral I as integral from t is equal to 2 to 3, because when x varies from 0 to log of 2, t varies from log 2 to 3, right? So here we have 2 and here we have 3, right? And in the numerator we have greatest integer e raised to x. So for e raised to x we can write t minus 1, and in the denominator we have 1 plus e raised to x, which is t. So here we have t, and for dx we can write dt over t minus 1, right? Okay, so now here we see that when x varies from 0 to log of 2, t varies from 2 to 3, right? So here we have 2 and here we have 3, and by the definition of greatest integer function, we know that when t lies between 2 and 3, then the value of greatest integer t is 2, right? But here we have to keep one thing in our mind. See, we should also find the value of greatest integer t minus 1, right? So if we subtract 1 throughout this inequality, we have 2 minus 1, then we have t minus 1, and here we have 3 minus 1. So we have 1, then t minus 1, and then 3 minus 1 is 2, right? So when t minus 1 lies between 1 and 2, then the value of greatest integer t minus 1 is equal to 1, right? Okay, so now this integral I can be written as, see, t is from 2 to 3, the value of greatest integer t minus 1 is 1, and the value of greatest integer t is 2, so we have 1 over 2, and here we have dt over t minus 1, right? So now we have a very simple, and it is a known integral, so we can take half outside this integral sign. So we have half integral from 2 to 3 and dt over t minus 1, right? Now we know that the integral of dy over y minus a is equal to log of y minus a, and here we'll make use of this. So we have half this is log of t minus 1, and the limits are from 2 to 3, right? Okay, now substituting the limits and taking the difference, I is equal to half, and here we have log of 3 minus 1, that is 2, and here we have 2 minus 1, that is log of 1. So this is half log of 2 minus 0, because log of 1 is 0, and this is simply half log 2, right, which can also be written as log of square root of 2, right? So the value of this integral is equal to log of square root of 2, which can also be written as log square root of 2 to the base e, right? So this is the final result.